Hi, I'm Randall Heyman, a mathematics academic. Welcome to my Corona Help playlists, where I make quick turnaround videos to help students and educators during the coronavirus outbreak. If you'd like me to make a video for you, then write me a comment under any of my videos or drop me an email. And if I think I can help you, I will. Okay. Let's just move this across slightly so we can see the email address if you want. Okay, I got a call, an email from Subarata, who asked me about this recurrence relation that I've put up on the screen. Now, in this case, I'm going to do something a bit cute. Normally what happens is we're given this recurrence relation, we may be given some initial conditions, and the aim is actually to work out a formula for AN, a formula of this sort of form, like a closed form. In other words, you can just put in the values of N and it'll spit out the value. In other words, the way to think about it is, if under this system here, if I wanted to work out what's A in million, I would have to start with A1 and 2 here, and then work out A3, from A3 work out A4, etc. And I have to work all the way up to a million. Here, of course, I can just put a million in straight away. So that's why we do it. Makes it a lot easier than to work out particular values of AN. Okay, so now normally what we would do is go through this process where we use what I've put here and here to construct this. But in this case, we're told this. So all we have to do is actually prove that it works. So how could we do that? So this is being, as I said, a little bit cute. And Subarata, if you want me to do it the other way, I'm happy to have a look at that in another video. But okay, so let's do this in blue. So well, this is all what we got to show, and we know the formula. So 7 AN minus 1, well, that equals 7 times 4 N minus 1 minus 3 N minus 1 plus 1. And that equals 7 times 4 to the N minus 1 minus 7 times 3 to the N minus 1 plus 7. Next one, I'm going to look at this thing, negative 12. Oh, actually, I can write it there, negative 12 AN minus 2 is equal to negative 12 times 4. So I'm just, for this AN minus 2, I'm just using this, but substituting N minus 2. So 4 N minus 2 minus 3 N minus 2 plus 1, and that equals negative 12 times 4 N minus 2 plus 12 times 3 N minus 2 minus 12. And then I suppose I could just put the number 6 equals 6. And now I can, now I can just total this. So, I'll just do a couple of totals, if you like. So here I've got 7 AN minus 1 minus 12 AN minus 2 plus 6. Now, why have I done all this? Well, that's what we've got up here. So all I have to do, so I need to show, oh, actually, let me write what I've got here. So what have I got? I've got 7 times 4 N minus 1 minus 12 times 4 N minus 2. That's all the N minus 2 terms. Then I've got minus 7 times 3 to the N minus 1 plus 12 to the 3 to the N minus 2. And then I've got plus 7 here, plus 7 minus 12, so that's minus 5. And here I've got plus 6, so that's plus 1. Now, what I want to do is I want to show this equals AN. Yeah, because that's what we've got up here. So how could we do that? Well, we need 4n here. We need to re-express this in terms of 4n, I suppose. So this is 7 on 4 times 4 to the n minus 1 minus 12. Well, that 12 is actually 3 times 4. So I'll do it this way. This might be easier. 4. Actually, sorry. That should be an n now. Minus 12 times 4 to the n on 16 minus 7 on 3 to the n plus 12 on 9, 3 to the n plus 1. And so this is equal to what's 7? Let's just go over here. 7 on 4 minus 12 on 16 equals 7 on 4 minus 3 on 4 equals 4 on 4 equals 1. So this bit here, I can just write as 4n. Okay, now the next bit, the 3n bit, let's rub this out. We're just using this as a little scratch pad over here. What have we got? We've got negative 7 on 3 plus 12 on 9, and that's all times 3 to the n. And that equals, this bit here is negative 7 on 3 plus 4 on 3, 3 to the n, and that equals negative 3 on n, which is negative 1. So I'll just write here negative 3 on n plus 1. And that's exactly what we're told is AN. So that's a bit of a roundabout way of doing it. It's probably not what was intended by the question. So I think what I'll do is this only occurred to me when I started working on it, when I saw that they're actually giving you the solution. So anyway, this is an interesting way to approach it. What I'll do another video and I'll go through it in the normal way for Subarata. If you've got any questions on any aspect of maths, just drop me an email or comment below any of my videos. And if I think I can help you, I will do so.